We are live now. Good day to all. Hearty welcome to each and everyone who have gathered for our SSC e-talk series conducted by Saveetha School of Engineering, Saveetha Institute of Medical and Tech. Today invited talk will be the 18th talk of the series. I am Dr. Deepak Arun, Associate Dean, International Affairs, Saveetha School of Engineering, Saveetha Institute of Medical and Technical Sciences. At the outset, I extend my sincere thanks to sincere thanks to our respected Madam's continuous guidance, support, and motivation. I also thank Principal Sir and Vice Principal Sir for their support. Today, we have with us Dr. Salim and Ms. Saveetha from Swansea University. Dr. Salim is currently working as Associate Professor in Engineering, and he is also Director of International Partnerships, Swansea University, UK. He lived, studied, and worked in UAE, Kenya, and Malaysia, and presently based in UK. He traveled extensively and delivered research talk around the globe. He has research expertise in CFD, urban fluid mechanics, turbulence modeling, and fluid structure interactions. He presented in various countries such as Hong Kong, USA, UK, Italy, Japan, and Australia. He also a reviewer of numerous international journals. He has H index of 11. He is going to present on the topic past, present, and future of engineering simulations, computational fluid dynamics. I'm very happy to welcome Dr. Salim and Dr. Ms. Saveetha once again. Now, I request Ms. Saveetha to give a very brief introduction about Swansea University. Followed by that, Dr. Salim will give his technical talk. Over to you, Ms. Saveetha.
Thank you, Dr. Deepak. Good afternoon, everyone, and thank you for joining us today for this session. I'll quickly talk about Swansea University, where we are, our rankings, location, and everything. And then I have my contact details on a slide. So I work as the regional manager for South Asia, and I'm based out in Delhi. So after the session, if you wish to have more, query in regards to applying to Swansea or any of our courses, you can get in touch with me. Okay, to start with, talking about the rankings of this university, Swansea is one of the most prestigious universities in the UK, and we've been recently ranked as a top 24 UK university by Guardian University Ranking 2021. Apart from that, we also have very good rankings in terms of our student satisfaction. We are top 10 for career prospects. We are top 5 for a teaching excellence framework, which is a ranking given to universities as per their performance. So gold is the highest rating which is given to a university, and Swansea has got a gold rating for that. We are also we are also the highest ranked university in Wales. We've been named as Welsh University of the Year for 2019 as well as 2020. Also one of the most affordable cities in the UK, so it's really pocket friendly if you wish to come and study with us. We are a traditional university. We were founded in the year 1920, and we are completing 100 years this year. The total strength of the university is about 21,000 students, out of which about 3,500 are international. And we have 2 campuses very close to the city center, very unique locations, very beautiful locations. You can see in the inset the pictures of our 2 campuses, Singleton Park campus, which is located inside a park, and Bay campus, which is located on a beach where our College of Engineering is located. In terms of where we are in the UK, the map that you can see on the screen, UK's map, the green bit is Wales, and we are located at the south coast. So we are a coastal city, and we are lined by the beach throughout. It's a beautiful, beautiful location, beaches, mountains, really nice, very friendly, vibe from the city you get when you come here. So Singleton Park campus, I'll just quickly go through because this is our traditional campus. It dates back to 100 years. We have our Arts and Humanities, Health and Human Sciences, Law, College of Science and Medical School located on this campus. Bay campus is a newly built campus which was built in the year 2015, and our College of Engineering and Department of Computer Science is located on this campus. After this campus was built, we are the closest university located to a beach, nearest to a beach in the world. So this campus is literally located on a beach. It's like a personal beach available to students. It's a very beautiful location. But apart from that, we've invested a very huge amount in the infrastructure and facilities to specially cater to students who are studying onto our engineering programs. So the campus was built keeping in mind that these teaching and learning facilities are essential for students studying on an engineering or a computer science course, and that is why this campus came into being. Also, a lot of opportunities for sports, more than 60 different sports teams, including 2 cricket teams and over 100 different societies. So along with your program, if you wish to carry on some co-curricular activities, if you want to participate in sports or similar areas, then there's a lot of opportunity to do that with Swansea University. A lot of opportunity to beach and water sports because we are a coastal city. There are a lot of you can do water surfing, you can play beach volleyball, and a lot of other sports that you can play when you're there in Swansea. As a city, it's a very beautiful, vibrant city. We are the second largest city in Wales, and we have a very vibrant city center, more than 200 shops, a very nice market. There are a lot of cultural places to visit in Swansea. There are theaters, museums, waterfront museums. There are beaches which are just half an hour away from the main city. So there are a lot of places that you can visit within the city and near the city and within Wales as well. The picture that you can see is our maritime quarter. And again, you can see how beautiful this is. There are big, beautiful ships that you can go and see if you have interest. Some more pictures of the city. And these are my contact details. So if you wish to get in touch, we have an India office, and I can, me or my team can answer your questions, anything related to our programs or entry requirements or scholarships or anything that you would wish to know, we can answer that. Thank you so much.
Thank you, Ms. Saveetha. Now it's over to you, Dr.
Great.
Sorry.
So I'm going to share my screen. If you can just bear with me, and there we go. So I'm going to have that. Can you all see my screen?
Yes.
Good. First of all, thanks to Dr. Deepak and Saveetha University for inviting me to give this talk. It's a shame that I can't be there in person, but then with technology, at least we can still deliver this. We can still be in touch. And thanks to Shweta, that was a really good introduction to the university. So I was in India earlier this year. So it was a beautiful place, and I look forward to visiting India again. I think I was in Chennai, Bangalore, and Delhi. We were just talking about it. And that was just before COVID restricted all our traveling. So again, it's an interesting time. 2020, we'll all remember that. And I hope you're going to enjoy the talk we're going to deliver today. So my discussion will be really about computational fluid dynamics, so CFD. Shweta, if I could please ask you to mute.
Yes.
So there's a bit of background noise. Yeah, that's fine. Thank you so much. All right. So again, there's no need to introduce myself because Dr. Deepak did a very good introduction. I'll just jump straight into my research interest, and that's related to sort of what I do in my expertise. So one of the things I focus on is air pollution and urban cities. So you can look at that is, I don't know if you can all recognize that. That's the tallest building in UK. It's based in London. That's called the Sherd. There's the Shangri-La Hotel up there and an observation deck. It's near the tower, so I'm going to use my cursor. That's the Tower Bridge in London, the River Thames. And the interesting part is we were trying to identify the airflow and the interaction with the building. So here you're not just looking at air pollution, but you're also looking at the wind loading on buildings. So tall structures, we're looking at the deformation and the stresses, so that when you're designing a building, you wanted to ensure the stability. You wanted to use the least material to ensure the best sort of air circulation at the base of the building for the pedestrians. But at the same time, you wanted to ensure that if someone is having their coffee at the top floor, they're not going to get seasick, you're not going to be swaying your building. So there's a lot of interesting research that you can do with that. And that's a different part. The first part that I showed you, or the first photo, was a numerical investigation, CFD. And here we're looking at a wind tunnel. This is another city. That's a tall building in China. It's in Shanghai. So that's the Shanghai Tower. And I do travel quite a lot to China. We also do research collaboration, and we have academic partnerships in China. You have opportunities to study around the world if you join us. And within the wind tunnel, you also could do investigation. You could look at wind loading on buildings. You could look at air pollutions in cities. You can look at pedestrian thermal comfort. But there's a main difference between the two. One is a numerical investigation. One is a wind tunnel physical experiment. Now, usually I'll ask questions. I know this is a different platform, and I'll get, if I was there in person, I'll pose a question to you guys and you'll be able to answer. But today I'll sort of ask the questions and answer them on my own. So it'll be interesting. So the wind tunnel, there is benefits to using wind tunnels, and there's benefits to using numerical investigation. I'll pause for a minute and let you think about it. Which one would you think is better? Do you think a wind tunnel is better or an experiment is better? If you were an engineer, civil engineer, mechanical engineer, a wind engineer, and you're looking at the airflow in your city, which one do you think would be a better tool? Will you go for a numerical investigation, or will you go for wind tunnel? So I'll give you a moment. I'd like you to think about it. Then I'll try to answer the questions on my own. All right? So kind of have a mental note. Think about it. Which one will you choose, and why will you choose that? So it's interesting because sometimes we'll prefer using experiments, and sometimes we'll prefer using numerical investigation or simulations. Experiments are close to reality. They provide you a lot of detail, and they're the closest to reality. That's the experiments. While numerical investigations are easier, convenient, low cost, very easy to communicate. So you can do the simulation. I could then very quickly use photos, images to illustrate my point to a client. And the client could be in America, could be in Australia, could be in China. So I could do it on my computer, work from home, and send those predictions to another country. So I'll move on. Some of my research interests, so if you like to read my papers, you want to get in touch, so you could get in touch with Shweta to ask about admission processes and the programs we offer. But if you have any questions about the research, please do drop me a line. I'll leave you my contact details. I'll also leave you links to my Google Scholars or to some of the projects there. One of the things I'm passionate about, in addition to that, in CFD, is we work a lot with our students, not just PhD students, but even undergraduate students or master students. So when you're doing your undergraduate degree or your postgraduate, means your master's degree, you'll get an opportunity to embark on some of this research. And here are examples of publications that I did with my students. So this is Andrew Davidson. He just completed his degree in 2019, and now he's working in Scotland. I have another student. These are both undergraduate students. In fact, that one is also an undergraduate student. As your research project, you'll be encouraged to use some of this knowledge, some of the simulations, and to do a project. And they then publish papers. And these papers were presented at conferences. They got scholarships from the IMIKE, the Institution of Mechanical Engineers. They got about £1,000 to present their papers at conferences. Some of this were in London, some were in Hong Kong. And then you get to publish, and that looks really good on your CV. So we really encourage our students to do industrial-based projects or research projects. Okay, so I'll move on, and we'll talk about that. So engineering process, just going to move this away a bit there. So what is an engineering process? What do we tend to do in engineering? Now, you'll have learned this, whether you are designing an aircraft, a building, a mobile phone, a software, a piece of software, you always go through this design process. You always need to talk to your clients, identify the problems, you do research, you do brainstorming, then you come up with a solution, you construct a prototype, you test it, and you then identify your results. Now, the design process where I'm going to focus today is the analytic part, computer-aided engineering. You also learn to do computer-aided design, things like SolidWorks or AutoCAD. You also do computer-aided manufacturing, whether it's CNC machining, whether it's using rapid prototyping, whether it's using laser cutting, and part of design. So whenever you do a product, whether it's the new iPhone that is going to be announced maybe next week, or you're going to build a whole aircraft, you sort of go through this process. And it's a very integral part of an engineering design. But today, what I wanted to focus on is the stage number 4, which is the analyzing part. How many of you have watched this movie? Usually, again, if you have not watched this movie, I'll encourage you to. It's a very, very powerful, inspirational movie. And this movie encapsulates what I'm going to be discussing today. The processes of engineering analysis are threefold. So you could do analytic, and that's an example of me delivering my talk when we went into lockdown in March. So I also teach engineering analysis to first-year engineering students, which is purely mathematics, application of mathematics to engineering. And when we got into lockdown, I had to use Zoom. So you can just see me working and trying to teach trigonometry and also partial differential equation, multivariate engineering. This is some of the equations you're going to encounter and you'll already encounter. The other thing that you do in engineering is experimental. That's a wind tunnel experiment. That's from the movie. So that's analytic. Then we had experiment. And you can see me standing in a wind tunnel. That was in Japan when I did my postdoc. And it's interesting because you could also run experiments. But finally, we'll look at numerical or computer, which is CFD, airflow around aircrafts. So let's now move to computational fluid dynamics. And the topic today we are discussing is the past, present, and future of simulation. Where are we heading? What is all this thing to do about CFD? Why is it important? How is that going to get to employable? How is that going to improve your career prospects? So let's look at the evolution of engineering simulation. Now, this is something delivered by Boeing. This showed us the research. This was produced in 2005. But what they wanted to demonstrate here was over the years, in the past 2 decades or 3 decades now, from 1980, the prevalence of CFD, computational fluid dynamics, the number of experiments and the way that has evolved as we increased our computational capabilities and accuracies. Now, when I was born in 1993, the computers wasn't very powerful. The internet wasn't even founded yet. So a lot of the investigation was based on wind tunnel. Now, previously I said wind tunnel is accurate, but it's very expensive. And that's why we want to move away from experiments into CFD because they're more convenient, they're cost effective, they're time efficient. So previously, when Boeing was doing their aircrafts in the 1980s, when they were building the 767, these are now out of production. We are now into the Dreamliner 787. They relied heavily on wind tunnel. So every time they changed the design of the air wing, when they were trying to investigate a new wing, they had to do a wind tunnel experiment, and that's 77 runs. But then over the years, that has decreased, and you can see we're increasing the number of CFD simulations. So in 2010, when both the Boeing Dreamliner and the A380 was in production, 80 to 90% of the design was done in computers, and that was in 2005. Now imagine we're in 2020. So the future of engineering is really in running simulation. And that's something we encourage a lot of our students to do, whether it's undergraduate or masters. We work very closely with Airbus. You'll see some of the examples. Students do industrial placements with Rolls-Royce. So in Wales, we have a factory for Rolls-Royce. If you're doing our aerospace engineering or mechanical or even civil, you get to do projects related to material engineering with the turbines of the aircraft. And a lot of this, although you still need to do experiments, the skills that employers are looking for are in numerical investigation. A lot of people talk about artificial intelligence, and that's fantastic, or robotics, but that's the computer science part of it. Within engineering, the future is really on simulation. And why? Because it's cheap, it's convenient. We can see with lockdown, you're forced to work at home, so you could run your simulation at home. You don't even need to go physically to your workplace or to the research center. You could do your simulation. You could connect to HPC, high performance cluster. You could send your work there, get your tasks done. You could then analyze your data, write your report. Some other examples of research projects that I've been involved in, and I've encouraged students to do projects at undergraduate, and we'll talk about some of the things that I do with my PhD students. That's Shinjuku. So again, that's a city in Japan. And you can see that was the wind tunnel model and the numerical investigation. I'll give you some time. I know it takes a bit of lag before the images appear on you. This is a project that I did with my student, another student, where we investigated a new train station being built, and we wanted to identify the air pollution and airflow around the new station, because that's going to be the taxi ring. That's where you're going to pick up and drop off the passengers so that you get into the station. And we wanted to investigate the natural ventilation around the building. So there's a lot of exciting work that students get to do and then present their work, and that allows them to go improve their CVs and go when they're doing an interview. Another thing we were looking at is a new museum. That's the Victoria and Albert Museum in Dundee. And you can see this are 3 different students who did projects, and then we compiled them and we worked on air pollution and air ventilation around the new museum. Some other things, this is our IMIKE, is the Institution of Mechanical Engineers. That's our team at Swansea University. You can see them building the Formula Student car. But apart from building the car, there are other exciting things you could do. You could do there. We have the race simulator. So if you're interested in things like virtual reality, you're interested in racing, you could physically build a car. But in addition to that, we needed to do investigation. So you could see our students doing works. So you design the car. You also need to do structural analysis, because you need to build the chassis and make sure that it's structural integrity, especially during a crash. So you need to do crash test. You also look at the aerodynamics of the car. So there's the projects that students have done where they investigated the front wings and they published papers. You could do things like intake manifolds. Again, we encourage students to then publish their work at conferences and go for competitions or things like the Formula Student. So if you're interested in automotive engineering or mechanical engineering, this is something you could work on. You could join the team, you could do research projects based on that, you could look at the aerodynamic or structure analysis. Let's look at other projects. We wanted now to go to something else. So here we looked at structure analysis separately, and we looked at aerodynamic loading on cars. Let's look at something different, fluid structure interaction. Now that's something new. Previously, you looked at structure analysis separately, which was the finite element analysis, and you looked at CFD, computational fluid dynamics. But with them coming together, I hope that a lot of you can recognize that very famous picture. That's the Tacoma Bridge when it collapsed due to wind loading, when it hit the natural frequency. And there's been a lot of research on that. So again, if you're a mechanical engineer, structural engineer, civil engineer, wind engineer, this will be of interest to you, where they designed a bridge, but it collapsed because it interacted with the wind. So it was fluid dynamics and structure interaction. How do we design that? When we saw previously the tall building, the shard, we were interested in the interaction between the two. So things like the Burj Khalifa in Dubai, when you're building tall buildings, or even in Japan, one of the main consideration is the wind loading on those buildings. You wanted to ensure the comfort of the occupants, but also you wanted to ensure things don't collapse. And why is that important? We're going to combine CFD and finite element analysis in something called fluid structure interaction. And that's the new area. If you start doing research, you've seen the past decade. So when I did my PhD in 2010, it was mainly just computational fluid dynamics. But if you now start looking at the publications and the type of research, the type of jobs that you can get in industry, there's a lot of interest in fluid structure interaction where you combine both finite element and CFD, couple them together and bring the investigation. So if you come across ANSYS or a lot of those tools allows you to do the coupling of both fluids and structures. This is another example. I told you this is Kevin Marangi. He did his research and we presented the work just 2 years ago in London, but now he's doing his master's in Switzerland and is planning to do his PhD. And this is another competition held by the IMIKE. Apart from the Formula student, you could also build drones. So again, it's a global competition where students are challenged to design a drone. Physically, you have to build it, but before you build it, you have to select the right materials, the right wings, and you also need to do some investigation. So this is where a student did his project trying to identify the wind loading when normal wind conditions or when there's a storm, for example, when you're operating during a storm. And that's another paper. I've left the link there. I'll leave all the links at the end. I'll encourage you to take a photo, and you can always explore those topics. You can always download the papers and get in touch with me if you have any questions or you're interested in any of the research. I'm also happy to send it to you if you just drop me an email. Another example. All right, sorry, I thought someone was asking a question. Had some background. Okay. Another example of a fluid structure interaction is aerodynamic loading on trees. So this was a student who did this project in Malaysia, and now he's doing his PhD in New Zealand. And what I'm trying to encourage you is that if you are interested in doing things like CFD and you're interested in research, again, at Swansea University, we're very famous for our computational engineering. So at master's level, we do MSCs with industry applications, and I'll show you some of those examples later. But aerodynamic loading on trees, that's another publication where you were wanted to investigate how a structure or how a tree, interacts with during a storm. So that was the CFD part of it. And then we looked at the deformation of the tree, where we modeled the tree in CFD, looked at the wind loading, the pressure field, then we looked at the stress and von Mises stresses plus the amount of deformation. So how do engineering students learn? If I was to summarize all those stuff and give you the examples of the things we do. This is civil engineering students. That's the building that Shweta was talking about at the Bay campus. That's where I'm based. So during Easter, civil engineering students need to do surveying. There's opportunity for you to join things like the Swansea University race team. There are presentations. So again, when you've worked on your project, whether you do an experiment project or numerical investigation, we then invite employers and other academics to come and evaluate your work. So you have to do a poster and you engage and you show off your research projects. This is aerospace. So that's, again, the same building. I'm based here. And this is for aerospace. We have a flight fighter, and you can see we also have the A380 British Airways. We also have a wind tunnel at Swansea. So a lot of work is based on doing projects related to that. Rolls-Royce, again, industrial projects with Rolls-Royce. Things like A380s, trying to understand the wing structures, something you're going to learn in civil engineering, and you've already done that if you're a senior in undergraduate programs. Majority of you will have done things like solid mechanics or mechanics of materials, where you're looking at cantilever beams, or looking at the deformation, where there's Macaulay's theorem. This is another project our academics are involved with. It's called the Bloodhound. And they've also designed this, do wind tunnel experiments, but also CFD. I'll leave you links to that, and you can explore them on your own. What we prepare our students to be are leaders and champions of industry. You'll have heard of the announcement by the UK government that there's the new post-study work visa, and that's really exciting for us, because students who now do a master's degree or complete a degree in UK are able to stay for an additional 2 years. You don't need to be sponsored, so it's easier to get a job in UK, to get the appropriate experience. And if you plan to do a PhD, that's up to 3 years. So you will have heard of the post-study work visa. That's really an exciting part. So again, our master programs allows you to do a year of industry. These are some of our master programs I'm talking about. And the one that we are experts in, apart from mechanical engineering and electrical engineering, is computer modeling with finite element analysis. So again, you're going to learn numerical skills, whether you're interested in things like computational fluid dynamics or structure analysis. We have an opportunity to do a year in industry. And again, you can get in touch with Shweta. You can find out online on the kind of entry requirements. We do a lot of industrial collaborations, our employability and industrial collaborations. I'll show you some examples. I've spoken about Airbus and Rolls-Royce, but you can also do things like Jaguar and Tata. So in Swansea, we have the Tata still with Land Rover. So again, opportunities whether you want to go back to India or stay in UK or migrate to America. There's that incredible opportunity. I should also mention that our degrees are all accredited. So you heard that I was with the IMIKE. You can see our students doing projects with the Institutional Mechanical Engineers. But again, if you're a civil engineer, then that's the ICE. If you're a chemical engineer, that's Institution of Chemical Engineers, IET, the Royal Aeronautic Society. Our degrees are all accredited. We encourage our students, if you've completed your degree plus masters and you get enough industrial experience or work experience, then you can apply to be a chartered engineer. That's globally recognized. We also work with GE, Red Bull, and stuff like that. We have a very strong employability focus. You can see our masters with industry. We also have our undergraduate with EI in industry. And I know I've rushed through. I gave you a very quick overview, but I think it will also be incredible to give you opportunities to ask a lot of questions based on my research. So we did a quick summary, but Shweta has covered that. We are top in Wales for graduate prospects, for student satisfaction, and in terms of our research output. That's my context. Again, I'll leave it here for a moment. If you want to take a photo, you can find all my details on the website. You can get in touch. My email is there. You can get in touch through LinkedIn. You can look at some of those publications in Google Scholar or Scopus, all that details, and all of them are on the website. And as I said, those are the links that I covered. I'll pass the stage back to Dr. Deepak. And as I said, this is an opportunity for you to ask us questions. Again, anything to do with CFD. I know I did a very quick summary, but that was just to give you an overview. But again, it's going to be it's an incredible opportunity for you to ask us questions now. Thank you.
Yeah, thank you, Dr. Salim. Thank you for your wonderful presentation on CFD, and you have covered from the basics, and you have also shown lot of projects like what students are involved in your university. I'm sure our students would have definitely enjoyed it. Like before making the stage open, there are a few questions students have sent to me. So I will ask those questions, then I will ask the students in the live chat to ask you. So the first question is, it is from a first year student. He asks, give me guidelines to pursue and expertise my career in CFD.
All right, that's a good question. So,
right.
So before you do CFD, the first important thing is to understand the fundamentals. So you have to do a lot of reading into fluid mechanics. So understanding the basic of fluid mechanics, and also again, linking that to the mathematics, because CFD, computational fluid dynamics, is really the numerical investigation of the fluid mechanics principle. So there is a combination of computer science, basics of computer science. You'll need to understand the fundamentals of fluid mechanics, the Newtonian fluids, understanding boundary layer theories, going into the Navier-Stokes equation. So generally, you're going to move, and I think that's what you're going to be taught at your first year, second year. You're going to learn basic of fluid mechanics, then you're going to move into Navier-Stokes equations. You'll also need to have a very strong mathematics background, things like partial differential equation. You'll need to understand the numerical analysis. So you're going to move from finite volume methods, how we move away from analytics to numerical prediction. Once you've gotten that background, the next thing you'll want to do is to start learning how to do SolidWorks, because you'll need to know how to do 3D modeling. things like SolidWorks. I don't know what you're taught at your university, Dr. Deepak. Is that SolidWorks or do you do AutoCAD?
Both.
Very good. Yeah, so once you've mastered SolidWorks, then you can only move to CFD, because within ANSYS, you'll need to first build your model. You'll need to understand the sort of assumptions you're making, and then you need to be able to execute your model. So I think hopefully that kind of gives you the flow. So master fluid mechanics and your mathematics at this stage. Great.
Thank you. Now let's open it. Audience. Anybody in the panel have any query? You can please go ahead and ask. Students?
Yeah, students always shy to ask questions,
Right,
isn't it?
right.
Don't be
So-
shy.
So what we can do is, like, maybe in case if there is any questions, I can ask them to make, then I can forward it to you, and obviously you can send it to before I end the session, there are a couple of interesting things which I can see in your slides. Basically, like the tie-ups which you have with industry. So how it works? Because now post-COVID, we are finding it very difficult to send our students for internship, like offline internship. Now, so is there any possibility of online internships with respect to the industry? If you have any collaborations with industry which you can refer, maybe for a 10 days, 15 days.
Yeah, so one of the things that's a good, so we have a very strong employability team within engineering and at the university, and some of them are academics. So I'm very close contact with them, because a number of our students are going to be joining us at our masters with industry placement. So we have a masters which allows you to do 1 year taught plus 1 year in industry, and those are the kind of considerations. You're exactly right about physical presence. So what we are doing is we are trying to get them to do online placements with industry, and a lot of guidance is provided remotely, but we're also exploring opportunities to do them abroad. So it's not just limiting them to UK, but international. And I think COVID has accelerated that opportunity, where now people are a bit more open to discussing things. Just like now I'm delivering this talk, we're engaging. I'm in UK, you guys are in India, and we're having a discussion. We don't have to physically be there. So there's a lot of incredible opportunity. And I think Swansea are looking at that. So if we were to partner, and if we had students from your institution who are interested to explore that, we could discuss. And but the first thing is to get the right skills. How do you prepare your CV? How do you find those placements? So we provide all those supports to our students. We prepare them on the onset. So the first year they get to learn how to do CVs, how to perform well at their interviews, how to ace the interview itself. And then we try to link them with different industries within UK and internationally. So a lot of that is shared. There's a lot of CPD, continuous professional development, and we're also exploring opportunities overseas. So maybe there's something we can discuss. I know it's a challenge, yeah, but it's something new and exciting at the same time.
Yes. We are quite open as a university, and we also very much interested to collaborate with Swansea, as I told you earlier in our previous discussion. So looking forward to it, and positively we can start sending few of our students for a short term where they can come there and do some project, and then later we can build on say for example, we can also even send for master's program later.
Correct.
This particular thing.
Yes.
Thank you very much. I should once again thank you for your wonderful presentation, and spending a lot of time even in the during the trial session and also today. Thank you very much. We'll meet soon. Good day to you, and also special thanks to Ms. Saveetha for her to join today. Thank you, both of you. Good day to all.
Thank you so much.
Take care.
All right. Bye now.
Bye.
Thank you.
Bye. Bye.
Thank you. Bye. Bye.